The solar storm of 1859, also known as the Carrington event, was a powerful geomagnetic solar storm in 1859 during solar cycle 10. A solar coronal mass ejection hit Earth's magnetosphere and induced one of the largest geomagnetic storms on record. The associated white light flare in the solar photosphere was observed and recorded by English astronomers Richard C. Carrington and Richard Hodgson. Studies have shown that a solar storm of this magnitude occurring today would likely cause widespread problems for modern civilization. The solar storm of 2012 was of similar magnitude, but it passed Earth's orbit without striking the planet. Carrington's super flare, from August 28 to September 2, 1859, numerous sunspots were observed on the Sun. On August 29, southern aurorae were observed as far north as Queensland, Australia. Just before noon on September 1, the English amateur astronomers Richard Carrington and Richard Hodgson independently made the first observations of a solar flare. The flare was associated with a major coronal mass ejection that traveled directly toward Earth, taking 17.6 hours to make the 150 million kilometer journey. It is believed that the relatively high speed of this CME was made possible by a prior CME, perhaps the cause of the large aurora event on August 29, that cleared the way of ambient solar wind plasma for the Carrington event. Because of a simultaneous geomagnetic solar flare effect observed in the Kew Observatory magnetometer record by Scottish physicist Balfour Stewart, and a geomagnetic storm observed the following day, Carrington suspected a solar-terrestrial connection. Worldwide reports on the effects of the geomagnetic storm of 1859 were compiled and published by American mathematician Elias Loomis, which support the observations of Carrington and Stewart. On September 1, 1859, one of the largest recorded geomagnetic storms occurred. Aurorae was seen around the world, those in the northern hemisphere as far south as the Caribbean. Those over the Rocky Mountains in the U.S. were so bright that their glow awoke gold miners, who began preparing breakfast because they thought it was morning. People in the northeastern U.S. could read a newspaper by the aurora's light. The aurora was visible as far from the poles as sub-Saharan Africa, Monterey and Tampico in Mexico, Queensland, Cuba and Hawaii. Telegraph systems all over Europe and North America failed, in some cases giving telegraph operators electric shocks. Telegraph pylons threw sparks. Some telegraph operators could continue to send and receive messages despite having disconnected their power supplies. On Saturday, September 3, 1859, the Baltimore American and Commercial Advertiser reported, those who happened to be out late on Thursday night had an opportunity of witnessing another magnificent display of the auroral lights. The phenomenon was very similar to the display on Sunday night, though at times the light was, if possible, more brilliant, and the prismatic hues more varied and gorgeous. The light appeared to cover the whole firmament, apparently like a luminous cloud, through which the stars of the larger magnitude indistinctly shone. The light was greater than that of the moon at its full, but had an indescribable softness and delicacy that seemed to envelop everything upon which it rested. Between 12 and 1 o'clock, when the display was at its full brilliancy, the quiet streets of the city resting under this strange light, presented a beautiful as well as singular appearance. In June 2013, a joint venture from researchers at Lloyd's of London and Atmospheric and Environmental Research in the United States used data from the Carrington event to estimate the current cost of a similar event to the US alone at $0.6 a euro 2.6 trillion. Similar events, ice cores containing thin nitrate-rich layers have been analyzed to reconstruct a history of past solar storms predating reliable observations. Data from Greenland ice cores, gathered by space scientist Kenneth G. McCracken and others, show evidence that events of this magnitude was measured by high-energy proton radiation, not geomagnetic effect occur approximately once per 500 years, with events at least one-fifth as large occurring several times per century. More recent work by the ice core community shows that nitrate spikes are not a result of solar energetic particle events, so use of this technique is in doubt. Beryllium-10 and carbon-14 levels are considered to be more reliable indicators by the ice core community. These similar but much more extreme cosmic ray events may originate outside the solar system and even outside the galaxy. Less severe storms have occurred in 1921 and 1960, when widespread radio disruption was reported. The March 1989 geomagnetic storm knocked out power across large sections of Quebec. On July 23, 2012, a Carrington-class solar superstorm was observed. Its trajectory missed Earth in orbit. Information about these observations was first shared publicly by NASA on April 28, 2014. See also. References. Further reading. External links. Carrington, R.C. Description of a singular appearance seen in the Sun on September 1, 1859. Monthly Notices of the Royal Astronomical Society 2013 €5. Bibcode, 1859 MNRAS 20. 13 CDOI, 10.109320.1.13. Bell, Trudy E. Phillips, Tony. A Supersolar Flare. Science at NASA. Brooks, Michael. Space Storm Alert, 90 Seconds from Catastrophe. New Scientist. Retrieved March 28, 2009. The largest magnetic storm on record, the Carrington event of August 27 to September 7, 1859. British Geological Survey. 2011. Retrieved March 28, 2009. Clark, Stuart. The Sun Kings, The Unexpected Tragedy of Richard Carrington and the Tale of How Modern Astronomy Began. ISBN 978-0-691-12660-9. Excerpts of articles from newspapers concerning the Carrington event.